Ever feel like your to-do list is expanding faster than the universe? Well, maybe not that fast. But the universe is expanding, and it's mind-bending stuff.
It really is. One of the most fundamental discoveries in modern cosmology.
So, to get us started, we're diving deep today into the mystery of the universe's expansion, using some really cool articles you sent over.
I think they'll provide a good foundation, yeah.
I have to admit, the idea that the universe is constantly growing and changing, well, it makes my brain hurt a little bit. Where's it expanding into? Is it like blowing up a balloon?
It's a common way to think about it, but
Yeah.
that balloon analogy can be misleading.
Yeah.
It kind of makes us imagine the universe expanding into some pre-existing space, but what's really happening is that space itself is stretching.
Yeah.
Everywhere, all the time.
So it's not like the galaxies are just flying away from each other through space. It's more like the space between them is growing.
Exactly, you got it. Think of those dots on a balloon again. As you inflate the balloon, the dots move further apart, right? But not because they're moving across the balloon's surface. It's because the surface itself is expanding.
Okay, I think that's starting to make a little more sense. But how do we even know the universe is expanding if we can't see the edges of it?
That's where redshift comes in. It's kind of like the Doppler effect, but with sound.
Okay, I remember learning about the Doppler effect back in school. Remind me how that works again.
So imagine an ambulance speeding towards you. The siren sounds higher pitched, right?
Yeah.
And then as it moves away, the pitch drops. That's because the sound waves are being compressed or stretched, depending on the motion of the ambulance, relative to you.
Right. So are we saying that light waves from distant galaxies
Yeah.
are being stretched as those galaxies move away from us?
Exactly. Light waves also get stretched or compressed depending on motion, relative to the observer. And with galaxies, we see this stretching as a shift towards the red end of the light spectrum. It's called redshift.
So red light equals a speedy galaxy.
Got it. And the more redshifted the light is, the faster that galaxy is moving away from us.
So this redshift, it's happening everywhere we look in the universe.
Pretty much. The vast majority of galaxies show this redshift, indicating they are moving away from us. And the farther away a galaxy is, the faster it seems to be receding. That was actually a huge discovery made by Edwin Hubble back in 1929, which led to what we now call Hubble's law.
Hubble's law. So there's actually a mathematical relationship between a galaxy's distance and how fast it's moving away.
You got it. Hubble's law basically says that the farther a galaxy is from us, the faster it's moving away. And this relationship is remarkably consistent throughout the observable universe, this consistent pattern of expansion. It tells us that the expansion isn't just galaxies moving through space, it's the fabric of space itself stretching.
Okay, I think I'm starting to get this, but it's pretty mind-bending. So if we were living on a distant galaxy, billions of light years away, would we see all the other galaxies rushing away from us too?
You would. The expansion of the universe isn't centered on any particular point. It's happening everywhere, uniformly. So no matter where you are in the universe, you would observe distant galaxies moving away from you.
So it's not like there's some central point that everything is exploding out from.
Nope. Not at all.
Huh. That's really interesting.
It is. It's kind of like baking a loaf of raisin bread.
Raisin bread. Okay, you've got my attention.
Imagine the raisins are galaxies. As the bread dough rises, every raisin sees every other raisin moving away from it.
Ah, I see. And even though we're inside the dough, we don't feel ourselves moving.
Exactly. The expansion is happening on such a vast scale that we don't notice it in our everyday lives, or even within our galaxy. It's only when we look at incredibly distant objects, billions of light years away, that the effects of the expansion become really apparent.
So this raisin bread universe, it's constantly stretching, constantly growing. But what's driving this expansion? Is there some kind of cosmic engine pushing everything apart?
That's the million-dollar question. One of the biggest mysteries in cosmology. We don't know for sure what's causing the expansion, but we have a name for it: dark energy. It's this mysterious force that makes up a huge part of the universe, something like 68% of the total energy density. And it seems to be the culprit behind this accelerating expansion. Think of it like this. Gravity wants to pull everything in the universe together, but dark energy is constantly pushing it all apart.
So it's like a cosmic tug of war between gravity and dark energy.
Exactly. And right now, dark energy seems to be winning. It's causing the expansion to speed up, not slow down, like we might expect if only gravity was at play.
This dark energy sounds pretty powerful and kind of spooky, to be honest. What do we actually know about it?
Well, that's the tricky part. Dark energy is really just a placeholder term for what we don't know. We can observe its effects on the universe's expansion, but we don't understand its fundamental nature.
So we know it's there, we know it's powerful, but we have no idea what it actually is.
Basically.
Yeah. That's both fascinating and frustrating.
It's true. That's the nature of scientific exploration. We often stumble upon more questions than answers, but each new discovery opens up new avenues of investigation.
So what does this dark energy mean for the ultimate fate of the universe? Is it just going to keep expanding forever, growing colder and darker as everything spreads out?
It's a question that cosmologists are actively trying to answer. There are a few different scenarios, depending on the nature of dark energy and how it interacts with the universe over time.
Okay, lay it on me. What are the possible endings to this cosmic story?
One possibility is what's called the big freeze, or heat death. If dark energy continues to dominate and the expansion continues to accelerate, galaxies will eventually become so far apart that they will no longer be visible to each other. Stars will burn out. Matter will become increasingly dispersed, and the universe will gradually approach a state of maximum entropy.
Maximum entropy.
Yeah, a cold, dark, and empty expanse.
That sounds bleak. Are there any other options? Maybe something a little less depressing.
Well, another scenario is the Big Rip. This is a more dramatic and frankly terrifying possibility. If dark energy's strength increases over time, the expansion could accelerate at an even faster rate, eventually overcoming the gravitational forces that hold galaxies, stars, and even atoms together. The fabric of space-time itself would be ripped apart in a catastrophic event.
Okay, that's definitely not the ending I was hoping for. Big rip. More like big yikes. Anything else on the table?
There is a third possibility. It's called the Big Crunch. In this scenario, the expansion of the universe eventually slows down and reverses. Due to the combined gravitational pull of all the matter and energy within it, everything would start collapsing back in on itself, leading to a super dense state, much like the conditions at the beginning of the Big Bang.
So it's like the universe is playing a cosmic game of yo-yo. Out and then back in.
In a simplified sense, yes. The Big Crunch scenario suggests a cyclical model of the universe, where periods of expansion and contraction alternate over incredibly vast timescales.
Okay, so we've got the big freeze,
Yeah.
the big rip, and the big crunch. 3 very different fates for the universe. How do scientists even begin to figure out which one is most likely?
It all comes down to understanding the properties of dark energy.
Okay.
Is its strength constant? Does it change over time? Does it interact with other forces in ways we haven't yet discovered?
So lots of unanswered questions.
Yeah. To answer these questions, cosmologists are studying the expansion of the universe in ever greater detail, mapping out the distribution of galaxies and measuring their redshifts with incredible precision.
So it's like a giant cosmic detective story.
You could say that.
Scientists are piecing together clues to figure out the ultimate fate of the universe.
Exactly. And it's a story that's still being written. New telescopes and space missions are providing us with more data than ever before, allowing us to probe the deepest reaches of the cosmos and study the expansion of the universe with unprecedented accuracy.
I have to ask, is there anything out there that could challenge this whole idea of an expanding universe? I mean, this stuff is mind-blowing. But is it really the only explanation for what we observe?
That's a good question. And scientists are always open to alternative explanations if they fit the observational data. But so far, the evidence for an expanding universe is overwhelming.
But I remember you mentioned something called the multiverse. How does that fit into all of this?
Ah, yes, the multiverse. That's a really fascinating concept. And while it's not directly related to the expansion of our universe, it does touch on some of the same fundamental questions about the nature of space, time, and reality.
Okay, I'm all ears. Tell me more about this multiverse.
The multiverse is a hypothetical idea that suggests our universe may not be the only one that exists. It proposes that there could be many, perhaps even an infinite number of universes, each with its own unique set of physical laws and properties.
Whoa. So it's like there are countless cosmic bubbles out there, each with its own reality.
That's one way to visualize it. The multiverse idea arises from several different areas of physics and cosmology. For example, in quantum mechanics, there's this concept called quantum superposition, where a particle can exist in multiple states at the same time until it's measured.
Yeah.
Some physicists have speculated that this could apply to the universe itself, meaning that there could be multiple versions of our universe coexisting, each representing a different outcome of quantum events.
So like a cosmic coin flip, heads or tails.
Ah.
but both outcomes happen in different universes.
That's a simplified analogy, but it gets at the basic idea. Another source of the multiverse concept comes from string theory, which is a theoretical framework that tries to unify all the fundamental forces of nature. String theory suggests that there are extra dimensions, beyond the 4 we experience. 3 spatial dimensions plus time, and these extra dimensions could be curled up, or compactified in countless different ways, each leading to a different universe, with its own set of physical laws.
So we might have these other universes right next to us, but we can't perceive them because they're tucked away in these hilly dimensions.
It's a mind-boggling concept. And while there's no direct evidence to prove or disprove the multiverse, it does offer some intriguing explanations for certain aspects of our own universe.
Like what? What kind of problems does the multiverse solve?
For example, the multiverse can help to address the fine-tuning problem.
A fine-tuning problem.
Yeah. This refers to the observation that the physical constants and laws of our universe seem incredibly fine-tuned for life to exist.
Fine-tuned.
If any of these constants were even slightly different, stars wouldn't form, galaxies wouldn't coalesce, and life as we know it wouldn't be possible.
So it's like the universe hit the cosmic jackpot, with all the right settings for life to emerge.
That's one way to put it, but the multiverse suggests that if there are countless universes out there, each with its own set of physical laws and constants, then it's not surprising that at least one of them would have conditions suitable for life. We just happen to live in that lucky universe.
That's both humbling and kind of terrifying. So we're not special, we're just one of countless possibilities.
It's a shift in perspective, for sure. The multiverse challenges our anthropocentric view of the universe, suggesting that our existence may not be as unique or privileged as we once thought.
But even if there are all these other universes out there, can we ever actually prove they exist? Or is this all just theoretical speculation?
It's a tough question. Direct observation of other universes may be impossible, because by definition, they would exist outside of our own space-time.
So we're stuck with just the theories.
Not necessarily. Some physicists have proposed that we might be able to find indirect evidence of the multiverse by looking for subtle signatures in the cosmic microwave background radiation, the faint afterglow of the Big Bang that permeates all of space.
So like cosmic fingerprints left over from the creation of the multiverse.
It's a long shot, for sure, but it's one of the few avenues scientists have for potentially testing the multiverse hypothesis.
Okay, I think my head is officially spinning. After all this talk of expanding universes and multiverses, so just to make sure I'm following this, the universe we live in is constantly expanding, driven by this mysterious force called dark energy. And there's a chance, however slim, that our universe is just one of many in a vast, perhaps infinite multiverse.
That's a great summary. It's a lot to take in. But it also points to how much we still don't know about the universe. But that's what makes cosmology so exciting, the constant pursuit of knowledge, the drive to understand our place in the cosmos, and the willingness to embrace the vastness and mystery of it all.
Well, I think we've given our listeners a lot to think about today. It really makes you appreciate the incredible scale and complexity of the universe, and maybe even the possibility of other universes out there, each with its own unique story to tell.
It really does. It's a humbling thought, isn't it? To realize that our little corner of the cosmos is just a tiny part of a much grander and more mysterious reality than we ever imagined.
You know, I'm going to be looking up at the night sky with a whole new sense of wonder and curiosity after this. Every time I see a distant star, I'm going to remember that it's part of a galaxy that's rushing away from us as the universe expands.
It's amazing, isn't it? And perhaps, just perhaps, there are countless other beings out there, in those distant galaxies, or even in other universes, gazing up at their own night skies, pondering the same cosmic mysteries that we are.
Okay. I think we've officially blown our listeners' minds today, so what blows your mind about the expanding universe, or the possibility of multiverse? What questions does it raise for you? Share your thoughts in the comments, and let's keep this cosmic conversation going.
And remember, the universe is vast and full of wonders. Keep exploring, keep asking questions, and never stop being curious.
Until next time, keep those cosmic minds engaged. And don't forget to like and subscribe for more deep dives into the mysteries of the universe.